Hi. Last time I did a little implementation of the AND gate on the board, Nexys digital system board. You've got this board right here. It's quite old, I would say, but it's still very nice board to program and to learn how to do FPGA. Still very powerful board and capable of many things. It's just the one issue of that you need to use the old software, which is called ISE 14.7. Oh, sorry. You need to call is a project navigator. I see. Well, this implementation uses the combinational logic, which is not independent from the previous states. It's very simple and immediate reaction to whatever input shows, then respectively the logic does whatever we ask it for. So this time we're going to use more of the sequential logic because we are going to support ourselves with the external clock. External by meaning of not being generated inside the FPGA by itself, but it's generated on the board. Fortunately, we don't need to solder anything new. We just set the jumper, and then the clock from outside or from the board is going to be fed into pin number A8 in our case. So let's go. We can start new project. We name it Blink LED. We use device as XC3S1000. This is what is built on the board XC3S1000, and then we can progress to another. FT256 is the package. The rest stays as default was, and then we can say OK. Now we need an initial source. When we define VHDL module, we name it again Blink LED, and then we need to define two ports, which is LED1, this is output, and then we need clock, which is input, and then we finish, and then little frame is generated for us where we can fill up the rest of needed items. So to save on time, I'll bring two signals in, which is state and count as a counter. It does count to 50 millions. We've got clock 50 megahertz possible to set on our jumper here. So to observe 1 second blink, 1 second, yes, 1 second or half a second blink, we need to divide the initial clock, which is massive for our eye. We won't be able to see it with our naked eye. Maybe with oscilloscope we can see that signal. And then we will bring the logic itself. So what we do here, we start our counter and then process with CLK. It's like CLK is the sensitivity list, like argument in function. That's little event here. I'll remove this one. When the clock rising edge happens, then we add 1 to the counter, or if it counts to that number, we reset the counter. And then we changing state to the opposite one. In this case, after this block happening, we ask, or we define the LED 1 to behave respectively. The CCLK has been just copied from the previous, which is not the best, I would say. The rest should behave. So now we can go and synthesize this. Yes, we want to save it. Oh, I forgot about one thing, which is our pin definitions, because we need to connect whatever we wrote here we need to connect to our hardware. To do it, we add another source, and then this one is called constraint file. We call it again blink LED pins, and in this file we need to define where the clock comes in. So we say this A8 comes from the datasheet here, A8, and then LED is going to be L14. So we call net LED 1 located on, I lost it, L14. That should be enough to okay, and then program generate programming file. Awesome. Now we can try to program the board. That's my previous file. We've got play LED. Oh, this one doesn't let us do it for JTAG. To do it, we go back here, right click, and then going for startup options. This one asks, let us program, but for programming the onboard EPROM. For like constant loading. When we do with JTAG, this program is going to be held in the memory of FPGA only until we power cycle. This time, yes. I had this problem before. Very often happens that the virtual machine stops a little program called adept from recognizing board. This time should be okay. Yes. and it's not working. Let's reset it. I'm looking for errors, and until now I found only this little thing here. The syntax is not correct. We've got equals thingy. This may be the culprit of our behavior. Let's try it again. This time it does its job. We've got that little LED happily blinking, but maybe we can extend it a little bit, adding another LED, which will do 2 LEDs alternating, and then we can add here LED doing not state, and of course we need to add the second LED to location L13. Will it work? And now we've got 2 LEDs alternating. Okay. There is a little board I made, a little spider web thingy, which does VGA connectivity. So in next video, these little things, they do nothing, don't worry. So there is a simple batch of ports which are fitting to the top, and what we've got here is signal R, G, B, and then V-sync and H-sync to do driving of VGA cable, and then we can try to generate simple, not video, just a picture on the VGA monitor. Of course, some of these boards are capable of doing HDMI, but I don't know yet how to do it properly. Anyway, that's it. Thank you for watching. Stay with me for our next videos. Bye.